Hello everyone, so my name is Wang Zixin and I'm the group leader of group A2F. So here is my group members. So I would like to first give an introduction about our reports. MFC management conducted a quantitative study aimed to identify the key factors influencing passenger satisfaction with LRT service. This survey is generally used to enhance service quality and ensure better meets customer needs. By using a range of statistical techniques, including parametric tests and non-parametric tests, the study can finally generate meaningful insight that can improve the LRT operations and customer satisfaction. Next, I would like to discuss about the question 1A. According to the normal probability plot, figure 1, the central value, which is between the age range 20 to 30, follow the expected straight line pattern of the normal distributions, while the data point at the higher age range, which is above 35, shows significant upward deviation from the line. This indicates that the presence of the right skew distributions, which is mean more older passengers than expected. The age is not normally distribution, especially due to the high upper tail and potential outliers. The reason why Mann-Whitney U Test is chosen is because to compare the mean in two independent groups. Besides that, sample size are sufficient for the central limit theorem to apply. There are two hypotheses in this test, which are null hypothesis, which refer to two mean age of the gender are the same, while for the alternative hypothesis, the mean age of both genders are not the same. Referring from the data here, N1 and N2 refer to the sample size of female and male, while the W1 and W2 referring to the total range age of female and male. So by using all the data here, we can calculate U1 and U2, and finally we get that U1 have a smaller amount compared to U2. So we will choose U1 as using to calculate the Z stats. So the Z stats we get like negative 1.76. So I would like to say is there is no sufficient evidence to reject the null hypothesis at critical value equals to 0.05 since Z stat is negative 1.76, which is within the range of negative 1.96 to positive 1.96. And also the p-value is larger than the critical value. We can see here 0.392 versus 0.05.
So thank you, Zixi. My name is Erica Counts. So I will present question 1C and D and question 4C. So for question 1C, this question requires us to calculate the probability that the sample mean age exceeds 26 years. So we first have to identify some key info that used in the formula. The first one is population means, which is 26.9, and this is given by the questions. And the second is population standard deviation, which is 7.5308, and this is calculated by using Excel. And the third one is sample size, and it is 19, and this is also given by the dataset. So we use Z-score because the sample size is greater than 30. So after getting the answer from Z-score, we may refer to the Z table and get the p-value, which is 0.1292. And since this is a right tail, so we have to 1 minus 0.1292 to get the probability, which is 0.8708. As a conclusion, there is approximately an 87.08% chance that the average age in a sample of 90 respondents is more than 20 years old. Next, for question 1D, the question requires us to determine the probability that the sample means age for between 23 and 25 years. So we use the same information as question 1C and use the Z-score as well. Since the Z is fall between the area of negative 4.91 and negative 2.39, so we have to minus the probability so that we can get the final probability, which is 0.00842. As a conclusion, there is a 0.84% probability that the sample mean age will fall between 23 and 25 years. So that's all for question 1C and D. Thank you.
Thank you, Erika, for the explanation. My name is Sarah Batusha, and today I'm going to explain about question 2A and 2B. So for question 2A, the question asks to determine whether there is evidence of significant difference in user perception of two facility quality items of the LRT service. So first of all, we need to put all the formula we got into the data, which is, first of all, we got the Z-score, which is 1.645. And then we put all the data we got into the confidence interval formula, which is P1 minus P2 plus minus Z-score times standard error. So at the end of it, going to get the confidence interval is negative 0.1757 and 0.0657. Going to explain about question 2B, which is asking about the test if the mean score of the passenger satisfaction of the female passenger are higher than the male respondent at 5% of sneaker level. So first, the null hypothesis is the population mean female is less than or equal to the population mean male, and then the alternative hypothesis is the population mean female are more than population mean male. So first of all, we need to find the t, which is the 0.0688, and then we need to find the degree of freedom, which is 71.747, which is 71, and then we put all data we got into the Excel, and then we got 1.994. So conclusion is T statistic is less than the critical, but T critical, which is making it 0.0688 is less than the 1.994. So basically we feel to reject the null hypothesis because at the 5 clinical level, there is not enough evidence to support that female has higher satisfaction than the male passenger. That's all for me. I proceed to the next person.
Hello, my name is Yabijan and I will discuss about question 3A and B. Question 3A is about hypothesis testing with related samples. Hypothesis testing is a type of statistical analysis in which you put your assumptions about a population's parameter to the test. It is used to estimate the relationship between two statistical variables. The variables used for hypothesis testing are based on the perceptions on quality of the facilities. It is to determine if there is a statistically significant difference between the means of sufficient seating capacity in the train, which is FQ1, and the proper conditions and maintenance of elevators or escalators, which is FQ3, or if there is a change has occurred between the same group over time. Null hypothesis is that the difference between the means of FQ1 and FQ3 is 0, whereas alternative hypothesis is that the difference between the means of FQ1 and FQ3 is not equal to 0. Hence, a two-tier test is carried calculation in Excel, and all of the values are round off to 3 decimal places. Alpha is 0.05 and the D bar is 0.189. Hence, the upper and lower critical values are determined, which is 1.987. Meanwhile, for T statistic, the value obtained is 1.602. Besides, for p-value, it is about 1.1127. Therefore, through T statistic and p-value, we do not reject the null hypothesis, as T statistic is not in the rejection region, and p-value, which is 0.1127, is bigger than the alpha, which is 0.05. We can conclude that there is insufficient evidence of a change in between the means of sufficient seating capacities in the train, FQ1, and proper conditions and maintenance of elevators or escalators. FQ to question 3B. One-way analysis of variance ANOVA is a statistical method for testing for differences in the means of 3 or more groups. In this report, we choose availability and accessibility of emergency information SS4 as our dependent variables, while the independent variable is frequency of travel. These data are chosen to determine if there are any statistically significant differences between the means of the SS4 and frequency of travel. Null hypothesis is the mean satisfaction score are the same across all frequency of travel groups, whereas alternative hypothesis in at least one group has a different mean satisfaction score. Hence, one-way analysis of variance ANOVA table, we can notice that there are degrees of freedom, sum of squares, mean squares, F statistic, and p-value. These data are all calculated in the Excel. The critical value is equal to 2.71, while the T statistic is calculated as 1.288, where it is obtained from MSA divided by MSW. MSA is 1.153, while MSW is 0.896. Besides, the p-value is approximately 0.284. Since the F statistics is lower than the critical value and the p-value is bigger than the alpha, we fail to reject the null hypothesis. Therefore, there is insufficient evidence to conclude that at least one of the mean satisfaction score differs significantly from the others among the 4 travel frequency groups. This shows that satisfactions with the availability and accessibility of emergency information is similar, no matter how frequently the passengers travel.
Hello, my name is Lim Jun Yi and I am presenting for question 4A, which is to select the appropriate variables and data to conduct the following non-parametric tests. In this case, I'm using the chi-square test of independence for question 4A, and the 2 variables that I chose are gender as well as private transport ownership. So to justify the selection of these 2 variables is because we are testing to see whether these 2 variables are independent association of each other. And for this case, the chi-square test of independence is specifically designed to determine if there is a significant association between these two categorical variables. So for this question, the first step is to calculate the observed frequencies, where I utilized Microsoft Excel to calculate, and I'm able to obtain that the female gender were in fact the majority, with 35 of them owning private transportation and 25 of them not owning it. This sums up to 60 of them for females and 30 for the males. The next step is to obtain the total number of people who do not own private transportation, which is 41, divided by 90 and multiplying by the total males, which is 30, where we can obtain 13.67. Similarly, we use the same step, but this time we multiply by 60 to obtain 27.33. The null hypothesis that is set for this question is that there is no association between gender as well as private transportation ownership, whereas the alternative hypothesis is that there is in fact an association between the two variables that are chosen for this particular question. After determining the null as well as alternative hypothesis, we now move into the test statistics, where we take the sum of observed frequencies minus the expected frequencies squared and divided by the expected frequencies. So in total, we will obtain a figure of 1.098. Moving on, we now calculate the degrees of freedom, V, where we use row minus 1 multiplied by column minus 1, and we will now obtain a figure of 1. The level of significance that we utilize in this question is 0.05, and with that, we can conclude with the decision rule to not reject the null hypothesis because the level of significance is 0.05 when p is 0.295 and larger than the level of significance. Therefore, there is insufficient evidence to suggest a significant association between the two variables that were selected for this question, which are gender and the ownership of private transport. With that, we'll now move into question 4b.
Okay guys, hi, good morning. My name is Pramod and I'll be presenting regarding question 4b, which is about Mann-Whitney test. So essentially, the Mann-Whitney test is a statistically significant difference in the passenger satisfaction with the availability and accessibility of emergency information, in this case SS4, between male and female passengers. So this is in a specific question. So for the variable selection, we've chosen SS4 for the satisfaction with availability and accessibility of emergency information, and an independent variable which is gender, so there's male and female. And the justification for why I'm choosing these variables is because SS4 is ordinal, it follows the Likert scale, and the assumption of normality may not hold. And the gender, well, in this case, consists of two independent groups, male and female, right? So it's justified, and I feel like because of that, the Mann-Whitney test is suitable. Okay guys, so in this slide we have the hypothesis, the decision rule, and the computing sum of ranks. So the sum of ranks contain male and female, which shows the sum of males and sum of females, which we will use in the next slide for calculations. So after calculating everything and we've gotten the Z statistic, it is shown that Z is 7.7033, right, which is more than 1.96. So because of that, we reject the null hypothesis and we conclude that there is sufficient evidence of difference in medians. Thank you.
For question 4c, we use Kruskal-Wallis test to determine whether there is a significant difference in service quality scores PS1 among respondents with different education levels. So why we choose service quality and education level as our variables? First, the Kruskal-Wallis test does not assume normality and is ideal when comparing with more than two independent groups on an ordinal scale, and PS1 service quality rating on a Likert scale, which is ordinal, and education level have more than two groups, which is 3. So that's why these two variables is appropriate for a Kruskal-Wallis test. So this is how we conduct the Kruskal-Wallis test. We first state the hypothesis. The null hypothesis is all population median are equal, and the alternative hypothesis is not all population median are equal. Second, we look into the decision rules, which is we reject null hypothesis if test statistic hash is greater than the critical value. Otherwise, we do not reject. After that, we may obtain rankings and sum the rankings. So this is the table for the total rank. After getting the total rank value, we can compute hash test statistic and finally get the answer, which is negative 1.1302. The critical value for 5% significance of level is 5.991, which is greater than the hash test statistic, negative 1.1302. So our decision is do not reject the null hypothesis, and we can conclude that there is no sufficient evidence to reject that the population medians are all equals. That's all for question 4c. Thank you.
So guys, I'm back for the conclusion, and to conclude, the statistical analysis shows that the most test results resulted in failing to reject the null hypothesis. Hence, it shows that there are no significant differences in passenger satisfaction across gender, education level, and travel frequency. Similarly, satisfaction with specific service feature such as seating capacity, emergency information, and elevator conditions did not differ meaningfully between groups. These results suggest that overall satisfaction with LRT services is relatively consistent among passengers. Thus, we suggest focusing on enhancing general service quality rather than targeting specific demographic segments in future improvements. So that is all from us. Thank you very much.